good news is, section 6.4 is inverse trig functions. Why is that good news? We already did that. So there's not a whole lot new in this section. Now we need to have a little bit of refresher though. When I use this symbol, what's my domain and what's my range? What numbers can I plug into sine inverse? What kind of numbers can I plug into sine inverse? Okay. What kind of answers do I get when I use sine inverse? All right, so remember what we had to do. Negative 1 to 1 is the domain. And the range was negative pi over 2 to pi over 2. Because remember, we had to look at the original sine graph, and we noticed that the original sine graph was not 1 to 1. So we picked a block of the sine graph where it was 1 to 1. The block of the sine graph that we picked was minus pi over 2 to pi over 2. So that was the domain of sine. To make sine 1 to 1, the domain had to be negative pi over 2 to pi over 2. So that becomes the range of sine inverse. So sine inverse, you can plug in numbers between negative 1 and 1, and it gives you angles between negative pi over 2 and pi over 2. Now, what if I wanted to write these angles in degrees? What's negative pi over 2 to pi over 2 in degrees? Negative 90 to positive 90. So in this section, we're going to work in degrees quite a lot instead of radians. That's okay. We just need to know that our range when we're dealing with sine inverse is angles between negative 90 and positive 90. All right, and then we did a very similar thing for cosine inverse. Again, we drew the graph of cosine, and we saw that cosine was not a 1-to-1 function. So we had to limit its domain. And that gave us a range. For cosine inverse, the domain is exactly the same. The numbers that I can plug into cosine inverse is I can plug in any number between negative 1 and positive 1. But the range was different. What kind of angles does cosine inverse give me? 0 to pi. Or in degrees, 0 to 180. And then finally we talked about tangent inverse. And what we figured out with tangent inverse was the domain was all real numbers. We could plug in any number in the whole real world we wanted to. And the range turned out to be angles between minus pi over 2 and pi over 2. But you don't get the equal to there because for tangent, that's where the asymptotes occur. The asymptotes occur at pi over 2 and negative pi over 2. So our range in degrees would be negative 90 degrees to 90 degrees. All right, so back in that section that we did in chapter 5, I might ask you questions like, what's the sine inverse of a half? And you would have gone to that chart, looked at it in your head and memorized that chart, and you would have told me the answer is, closing his eyes and looking at that helps. What's the sine inverse of 1/2? I'll take degrees or radians. Is it pi over 6? It is pi over 6. That would be radians. And what's the equivalent of pi over 6 in radian in degrees? 30 degrees. That one's 30 degrees. That's 30 degrees. How about the cosine inverse of the square root of 2 over 2? Pi over 4 radians in degrees. No, smaller than 60. 45? 45 degrees. Alright, so as I recall, if I gave you positive numbers like positive 1/2 and square root of 2 over 2, those were pretty easy. What if I was in a bad mood and I gave you negative numbers like sine inverse of negative 1/2? Well, the sine inverse one was the easy one with negatives. What happens if I give you sine inverse of negative 1/2? Isn't it just what? Except it wouldn't be positive pi over 6, it would be negative pi over 6. So sine inverse and tangent inverse were easy with negative numbers. You just make your answer negative. So this would be negative pi over 6 or negative 30 degrees. It was cosine inverse that was a pain in the neck, because cosine inverse gives me angles between 0 and pi or 0 and 180. It has to give me a positive angle. So for this negative value right here, I have to get an angle in quadrant number 2. So what's the angle that's equivalent to 45 degrees or pi over 4 radians but lives in quadrant number 2? 3 pi over 4 in radians. In degrees? Well, tell me how you would... How much? 135. And how would you figure that out? You would take 180 minus the 45. That's correct. Or you simply memorize the entire unit circle and then you know it. Alright, so here's what we're going to do new with inverse trig functions in this section. Here's a triangle. It's a right triangle. This angle right here, I don't know what this is. This is the angle theta. And the adjacent side has length 4. And the hypotenuse has length 9. I want you to solve that triangle. What does it mean to solve that triangle? Find all the angles and all the sides. Okay. One of those is pretty easy to do. What's pretty easy to find? The other side, the height. And why is that pretty easy? It's just Pythagorean theorem, you know, two sides. All right. So this height is, I'll call this y, I guess. 4 squared plus y squared is 9 squared. So y squared is 81 minus 16. 81 minus 16? $65. So y is the square root of 65. All right, now how do I find, well, I got to find two angles. I've got to find this angle theta, and I suppose I got to find this angle, I'll call this one alpha. Like Greek letters for my angles today. How do I find theta? Well, I'm going to use the fact that I do have a right triangle. Well, if this is theta, what two sides do you know? What two sides were given? Adjacent and hypotenuse. So I've got theta, adjacent, and hypotenuse. What uses adjacent and hypotenuse? Cosine. So I know cosine of theta is 4 over 9. How do I get the theta all by itself? What gets rid of a cosine? An inverse cosine. So theta is inverse cosine of 4/9. Is that one of the fancy angles that I've memorized? Unfortunately, no. So I grab my calculator and I type that in. Now, do I want to give my answer in degrees or in radians? In this section, we pretty much use degrees all the time. So I'm going to make sure my calculator is in degrees mode. It is. And I do a cosine inverse of 4/9. And when you do your homework on WebAssign, it will tell you round off to so many decimal places, probably. I'm going to say round off to 1 decimal place. So theta is 63.6 degrees. If I know theta is 63.6 degrees, how can I find alpha? 180. So alpha is 180 minus the right angle, which is 90, minus the 63.6, which is theta. And I grab my calculator. .4, rounding to 1 decimal place. 26.4 degrees. Questions on that? All right, so let's see what we have here. We've already kind of done some problems like this, but let's do a few more. How about the sine inverse of negative square root of 2 over 2? Negative pi over 4. How about in degrees? Negative 45 degrees. Tangent inverse of negative 1. Not undefined. Tangent inverse. I can plug any numbers in the world I want into tangent inverse. Why is it negative 45? Well, actually, it's because of the negative. It has to be in which quadrant? Tan inverse uses what quadrants? 1 and?
No, 1 and 3.
Not 1 and 2. It's not 1 and 3. Tan inverse uses angles between negative 90 and positive 90. So 0 to 90 would be quadrant 1. Negative 90 to 0 is quadrant number 4. Tangent inverse uses quadrants 1 and 4. The only one that uses 1 and 2 is cosine inverse. Cosine inverse uses 1 and 2. Sine inverse uses 1 and 4 also. Okay. So because of this negative right here, the answer has to be in quadrant number 4. So again, I look in my chart. Tangent of what gives me positive 1? Pi over 4, but this has to be in quadrant number 4, so we're going to write it as negative pi over 4, which is again negative 45 degrees. Same answer as before. Alright, cosine inverse of negative 1/2. Which quadrant does that need to be in? That's in the second quadrant because cosine is negative in the second quadrant. Correct. So, again, I look at my chart. What's the angle in quadrant 1 that has cosine inverse of 1/2? Pi over 3 or 60. Alright, so I need to convert that into quadrant 2. To convert it into quadrant 2, I take 180 minus 60, or I take pi minus pi over 3. Convert to quadrant 2, it's always 180 minus the angle, or pi minus the angle. So those are 120 degrees, and 2 pi over 3 would be correct answers for that one. I think I forgot my little inverse symbol on that one, but it doesn't really matter. What's the sine of 0? 0. What's the sine inverse of 0? 0, so it doesn't really matter if I forgot my little inverse thing. You get the same answer anyway. Alright, number 2. We did one like this a minute ago. Solve the triangle. Again, finding the third side should be pretty simple. To find the third side, find the third side. Side, not sine. Pythagorean theorem, so call that x again. So x squared plus 6 squared is 10 squared. So So x squared is 10 squared is 100, 6 squared is 36. 100 minus 36, 64. So x is 8. This is 8. That one comes out nice. All right, how would I find this angle theta? This time I would use sine, because this time the given information is the opposite and the hypotenuse. So sine of theta is 6 over 8. Theta is sine inverse of 6 over 8. 6 over 10. 10. So did I. Darn. And I recorded it forever, too. I recorded that I made a mistake. Oh, boy. Anyway, 6 over 10, the hypotenuse is 10. Sine inverse of 6 over 10 is 36.9 degrees. And so the other angle, again, I don't know what to call it. I'll call it alpha, I guess. Alpha is going to be 180 minus the right angle, which is 90, minus 36.9, 53.1 degrees. Questions on that one? So far it's easy. I think the next two questions I think are a little bit harder. So far we've done the easy stuff. Let's look at the next one. Determine the exact value of cosine of tangent inverse of 4/3. Well, there's two problems. First off, cosine and tangent inverse don't just cancel each other, do they? It's not like cosine and cosine inverse. So that's a problem. The other problem is tangent inverse of 4/3. That's not one of those famous angles that we've memorized. So I can't just look at the chart and pull the answer off the chart. So that's not so good either. All right. So here's what you're going to do in a problem like this. Tangent inverse of 4/3. I don't know what that is exactly, but I know that tangent inverse takes a number and gives me an angle for an answer. Tangent inverse, you plug a number into tangent inverse, it gives you an angle. Where tangent, on the other hand, tangent, you plug in an angle and it gives you a number. So they go kind of backwards here. I'm going to take this little equation that I just wrote, and I'm going to get rid of this tangent inverse. What gets rid of a tangent inverse? A tangent. So I'm going to do tangent on both sides. If I do tangent on both sides, I have tangent of theta is 4/3. And then I'm going to draw a triangle. It's a right triangle. There's theta. If tangent of theta is 4/3, what two sides do I know? Opposite is 4, adjacent is 3. Can I find the hypotenuse? Yeah? Hypotenuse is 5. That's a famous 3, 4, 5 right triangle. You're right. If you don't remember that, you use the Pythagorean theorem. That's fine. All right, so notice what we have now. We have cosine of tan inverse of 4/3. Well, I call that cosine of theta. Now I look at my triangle. What's the cosine of theta? Why 3/5? You meant adjacent and the hypotenuse, but you gave me the right numbers. Yeah, it's 3/5. Adjacent over hypotenuse. Questions on that one? You look like you wanted to ask a question.
So how is it that being cosine theta?
I called theta. Theta, I called it tan inverse of 4/3. I just called it that. Okay. This this one you could plug into your calculator because the answer comes out to be really, really nice. It comes out to be 3/5. Usually these come out with ugly square roots in them. Let's do another one of those. I'll just make one up. That one was, pre-packaged to come out nice. So let's say we want to do, I don't know, give me a function. You like sine, cosine, or tangent? Cosine. And then do I want to do sine inverse or tangent inverse? Tangent inverse. Give me a number. What, 21? Over 4. 21 over 4. Can I plug 21 over 4 into tangent inverse? What numbers can I plug into tangent inverse? I can't. For tangent inverse, I can plug in any numbers in the whole wide world. If this were a sine inverse right here, I'd have a problem. Can I plug 21 over 4 into sine inverse? No, because the only numbers I can plug into sine inverse are between -1 and +1. That would be too big. But because we chose tangent inverse, we can plug in any old number in the world. All right. So we do pretty much exactly the same thing. I'm going to let theta be the thing inside the parentheses. Tangent inverse of 21 over 4. So this is going to be, when we get all done, we're going to call this cosine of theta, and we'll figure that out. Again, I get rid of that tangent inverse. The thing that gets rid of a tangent inverse is a tangent. So I do tangent on both sides. Tangent theta is 21 over 4. Draw a triangle. Try to draw it to scale here. Because if this is my angle theta, then where's 21? 21 would be the opposite side, and 4 would be the adjacent side. Okay, so this time, this is not one of those famous 3, 4, 5 right triangles. What other famous right triangles do you know? Do you know any besides 3, 4, 5?
There's one that's like one of those
1 square root of 2. Usually the famous ones, though, are the ones that are all integer numbers, like 3, 4, 5. You know any others? Well, there's a 7, 12, 13. Try that one, that works, 7, 12, 13. And there are others. I can't think of any others right off the top of my head. Those are called Pythagorean triples, numbers that come out like that. Anyway, this time we use our calculator. We're going to have c squared is 4 squared plus 21 squared. So 4 squared plus 21 squared is 457. So c is the square root of 457. Definitely not a nice number. Doesn't come out to be one of those integers. So that's why, like I say, for the first problem we did, yeah, you could have used your calculator. Usually not, though, because usually the answers come out to be ugly like this. So what would our final answer be? What's the cosine of theta? Adjacent, 4 over hypotenuse, square root of 457. So again, usually they don't come out nice answers. The other one was rigged to come out nice. All right. Now, what if they don't even give you a number there? What if they give you a letter like X? Then what do? Really can't use your calculator now. All right, we're going to do the exact same thing. I'm going to write this tangent of sine inverse of X. I'm going to write it as tangent of theta. Where what's theta this time? Sine inverse of X. Okay. What gets rid of sine inverse? sine. So I do sine on both sides. I have sine of theta equals x. All right, I'm going to draw a right triangle. There's a right triangle. There's my angle of theta. If sine of theta is x, how can I label my triangle? What sides do I know? Opposite is x. Hypotenuse is 1. Very good. Think of this as being x over 1. Think of it as a fraction. It's x over 1. So we're going to call the hypotenuse 1. Can I find the length of the other side? I can't give you a number answer, but can I give you an answer that has the letter x in it? Yeah, we're going to have like an equation. So we're going to have, I'll call this y for right now. I'm going to have x squared plus y squared equals 1. So y squared is 1 minus x squared. So what would y be? Square root of 1 minus x squared. And I think I heard somebody say 1 minus x. Is the square root of 1 minus x squared equal to 1 minus x? Yes? When do square roots and squares cancel each other out? In this case, they do not cancel each other out because they're connected by subtraction. Subtraction. When do square roots and squares reduce each other? When they're connected by multiplication. If I had something like the square root of 9x squared, I could say that's 3x because they're connected by multiplication. But the square root of 1 minus x squared does not equal 1 minus x. I don't get to just square root each piece there. All right, so this is the square root of 1 minus x squared. All right, so here's my final answer. Look at the picture now. What's tangent of theta? Tangent's opposite over adjacent. So that's x over square root of 1 minus x squared. All right, this is a very, very common thing that we do in calculus. In calculus, we deal with something called integrals, whatever those are. And one of the techniques for finding integrals is something called trig substitution. And when you do trig substitution, you very often end up with answers that look like this. And we want to simplify them. We simplify them to have just x's in them. We don't want these complicated functions. We simplify. So that's what this is building up for. This is really a calculus skill. What's it good for right now today? Not a whole lot, truthfully. But when you get into calculus and you do this sort of thing, that's what you'll use it for. All right, on the back side. Hey, some word problems. Those are a good time. It says, an observer views the space shuttle from a distance of 2 miles from the launch. Express the height of the space shuttle as a function of the angle of elevation theta. And it gives us a picture, because I can't draw as we learned. So here's the space shuttle. There's its height up above. And we're 2 miles away. And theta, there's the angle of elevation. Okay, so what does it mean when it says express the height as a function of theta? What's your answer going to look like? What's that? Kind of like the last problem in the sense that it's going to have letters and stuff in it. Okay. I guess what I'm looking for is when I get all done, my answer should have h equals something. That's what it means to write h as a function of theta. That means we want h all by itself on one side, and over here on the other side we should have some stuff, and the stuff should have a theta in it. As opposed to part B Part B says express the angle of elevation theta as a function of h. So when I get all done in part B, what's my answer going to look like? Theta equals something with a bunch of h's in it. I just wanted to make sure we understood what those words mean, right? H as a function. That means we want h equals something. All right, and then I heard Brandon say, hey, let's use tangent. And I agree completely, because we know that if we have theta, h is opposite, 2 is adjacent, so that sounds like tangent theta equals h over 2. So what would my answer be for part A? How would I write h as a function of theta? I'm going to write it as 2 tangent theta. So there's the answer to part A. We get h all by itself. What's the answer for part B? How do I take this little equation that I wrote here and get the tangent? That's exactly correct. How do I get the theta all by itself? To get rid of a tangent, I do an inverse tangent. So theta would be inverse tangent of h over 2. Questions on that? Okay, and then the last problem. Kind of a similar thing. A 600-foot rope anchors a hot air balloon. So we've got a rope 600 feet long, the height of the air balloon. Express the angle of elevation theta as a function of the height. So again, what they're telling me here is I want theta equals something, and that something will have the letter h in it. Well, what am I going to do? Looking at the picture, what do you see? You see opposite and hypotenuse. What uses opposite and hypotenuse? Sine. So we know sine of theta is h over 680. So again, how do you get the theta all by itself? What gets rid of a sine? Inverse sine. So theta is sine inverse of h over 680. Find the angle theta if the balloon is 500 feet high. Grab my calculator and type it in, right? Sine inverse of 500 divided by 680. Theta would be, I get 47.3 degrees. Anybody have questions on anything?